Hey guys and welcome. In this video we are going to write a subroutine for hyperelastic materials. First let's see what is a hyperelastic behavior. A strain energy density function is used to define the stress-strain relation, which is commonly nonlinearly elastic, isotropic, incompressible, and independent of the strain rate. The most common materials that show this kind of behavior is rubber and some elastomers. In this picture we can see the difference between hyperelastic behavior and elastic behavior. Note that the hyperelastic behavior is reversible. Hyperelastic material models are categorized in three. First is the phenomenological behavior. The most famous one is the Ogden behavior, which is available in Abacus. Second is the mechanistic behavior. The most prominent one is the Neo-Hookean model. And third, and our goal, is the hybrid models, in which we can see the Gent and van der Waals model. We are focusing on the Gent models. Note that the difference between these models are only in the strain energy density function. In this picture we can see the difference between actual test and some material models. As you can see, the Gent model is one of the most accurate ones. So the Cauchy stress for hyperelastic materials is according to this relation, in which the U bar is the strain energy density function, I bars are the strain invariants, B bar is the Cauchy's left green strain tensor, and the J is the determinant of the deformation gradient. Note that the J and B bars are calculated using the deformation gradient, from which we can calculate the I bars. For calculating the F bar, we need the determinant of the deformation gradient tensor, from which we can calculate the B bars. Then we can calculate the I bars. Note that Abacus gives us the deformation gradient tensor, and we can calculate the rest by coding. So the Gent strain energy density function is according to this relation. We need three inputs for this equation. First the shear modulus, then the extensibility, and the last one is equal to 2 divided by the bulk modulus. Note that the bulk modulus of an incompressible material. If we compare this relation to the equation for Cauchy stress, we can see we don't need the derivation with respect to I bar 2, so we can make this equation more simple. At last, the Cauchy stress and the consistent Jacobian tensor are calculated using these relations. Now that we have this relation, we can write our desired subroutine. Continuing with the subroutine, this is the subroutine's header. I'm sure you are all familiar with. Then some parameters and our inputs, which is the shear modulus, then extensibility, then the D1 parameter. Then we need the determinant of the deformation gradient tensor. We can calculate it using this part. Then we need the F bar. So the relation is this. We can calculate it using the det parameter. And then we can calculate it using these loops. Next, we need the B bar tensor. We can calculate it using this part of the code, which is quite simple and I don't need to explain it. Then we have to define some terms for our Cauchy stress tensor. These terms are constants and we can calculate it using the equation that I showed you in the PowerPoints, and then can calculate the stresses for Abacus. At last, we need to define the consistent Jacobian matrix, which is this part of code. I tried to make this part of the code simple. However, the guys with strong coding backgrounds can make this part of the code really simple. So this is our subroutine. Now I'm going to test it on two simple tests. In this section, I'm going to test my subroutine such as shear test and uniaxial test. The properties that I've used are these values for my three inputs. My units are Newton and millimeters. So you have to be careful how to manage these values. Next, I used the full integration C3D8 elements, and let's go for the results. For the simple shear test, we can see the S12 stress, as you can see it here, and for simple uniaxial test, we can see the S11, which is in the X direction, as you can see it here. I've checked the results with the handwritten solutions and the results are correct. However, if you guys see a misinput or miscalculations, please let me know in the comment section. This concludes our video. If you find this video useful, please support me by liking and subscribing to my channel. Take care.